Georg Cantor by Marco Flores. Math 101, Professor Rodolfo Andrade. A great mathematician amongst mathematicians. Georg Cantor devoted much of his life to the untouched and unresolved topics in the mathematical community. While some mathematicians have made interesting discoveries in their part of history, Cantor's theory is one that would change the very idea of infinity. George was an opportunist who lived amongst brilliant minds and was part of history by founding set theory and introducing the concept of transfinite numbers. The life of Georg Cantor. The opportunist George Ferdinand Ludwig Philipp Cantor was born on March 3, 1845, in St. Petersburg, Russia, and died a father of 6 children and a husband to Valley Gutmann on January 6, 1918, in Germany. He was the son of George Waldmar and Maria Ann Bohm. Cantor's father was a successful merchant, and his mother came from a family of talented musicians. He inherited their talents and was an outstanding violinist. Georg Cantor's early life was focused on academics from a young age. Born in Russia, he went to primary school in St. Petersburg while also being tutored privately. At age 11, he moved with his family to Germany for his father's health, which was unfavorable to the cold winters of St. Petersburg. George graduated from the gymnasium, a senior secondary school in Germany, with an outstanding report. His skills in mathematics were exceptional, especially in trigonometry. With his parents' approval, he studied mathematics at the Polytechnic of Zurich for a couple of years until ultimately leaving it due to his father's passing. After his father's death, he moved to the University of Berlin, where he studied and received his doctorate in mathematics in 1867. There, Cantor met incredible people who helped influence his life and propelled him to become one of the most notable figures in mathematics. Cantor had the privilege to live amongst brilliant minds. Possibly the biggest influence he had were the teachings of Karl Weierstrass, who is best known for his construction of the theory of complex functions utilizing power series. Another was Leopold Krochner, who contributed to the theory of equation, elliptic functions, and theory of algebraic numbers. Although Krochner would defy and discourage Cantor's theory of set theory, Cantor learned from him and used his criticism to fuel his ambition. Edward Krümer, who introduced the concept of an ideal between integers to other integral domains, was also another brilliant mind that Cantor was fortunate to be around. Georg Cantor's biggest success would be a cumulation of teachings from his peers and the ambition he had to extend the knowledge of those who came before him. Cantor joined the Schellbach Seminar for Mathematics Teachers in 1868. In 1869, George was appointed to the University of Halle in Halle, Germany. While there, he was awarded the requisite habilitation in 1869 for his thesis on number theory. Habilitation is the highest academic qualification a person could achieve in Europe. Cantor would spend his career at Halle University in Germany. In 1872, he wrote a paper that extends the idea to an infinite number of points, provided they are distributed in a certain way, based on an idea due to Hermann Hankel. In the process of working on the Fourier series, Cantor began considering infinite sets with properties. Other consequences of his work were Cantor's first ideas on set theory, and ideas about irrational numbers. One person who helped Cantor reach his goal of set theory was Richard Dedekind. Dedekind never got fully recognized, but his ideas of infinite and what constitutes as a real number helped Cantor's set theory. Cantor showed that there are different sizes of infinity. He called it the smallest alpha null, which represents the infinite of transfinite numbers. The transfinite numbers are the sets of integers, rational numbers, and real numbers, but each is a subset of the next. 0, 0.0, 0.01, negative 0.1, 0.02, negative 0.02, Aleph 1 represents real numbers. Real numbers are larger transfinite numbers, like Aleph 1, Aleph 2, which this one will be 1, 2, 3, etc. A good way to look at it is by imagining a short line and a line that goes on forever. They are both infinite despite their length. This understanding of mathematics would help other mathematicians improve on their work. Georg Ferdinand Ludwig Philipp Cantor can hold his head up high knowing he helped history by living a life of opportunity. Unfortunate events helped pave his way to meeting incredibly gifted and hardworking brilliant minds that helped shape his future. Having the ambition to oversee Krochner's judgment and at the same time use his criticism to accomplish his goals showed how devoted Cantor was. His theory of set theory and introduction to the concept of transfinite numbers will forever help us understand math a bit more. Not all infinities are the same as they are. This thought is much like a short line on a long line, and like Georg Cantor once said, I see it, but I don't believe it. One of history's best mathematicians.